So we know that we can take this Boolean expression and we could factor b naught out. If we factored b naught out, we'd have a naught ORed with a, which anything ORed with its opposite is always going to be 1, so it simplifies to b naught. So that kind of method of factor and hope things will cancel out via ORing is definitely a valid approach. In the K-map, or the Karnaugh map, kind of encapsulates that process in a more systematic fashion. So I went ahead and took the function and turned it into a truth table, because this is just a regular sum of products, so it's pretty easy to go from one to the other. Right, this can go either way. And now I want to do the K-map. So this is a 2-input K-map, and there's 4 possibilities, right? 2 to the n, so that's 4 possibilities. So our K-map is going to have 4 cells, or it's going to look like a grid, right, with 4 cells. So I'm going to make myself a square. I'm going to cut it into 4 pieces. All right, and usually with your K-maps, you draw this little line here. That's not a very good line. Let me retry it. That's still kind of crappy, but whatever. All right. And we're going to say that this is our A-axis, and this is our B-axis. This is kind of actually a standard thing where you'll go the first letter in your truth table here, and then your second letter here, and eventually as these scale up, you'll have always your first letters here and your second letters here. So now, since this is our A-axis, we want to have each possibility for A. And really, there's only 2 possibilities, right? We could have A is a 0 and A is a 1. Same with B, we could have B is a 0, B is a 1. Now, let's look at this truth table, and we can use that information to figure out how to fill out this Karnaugh map. So here we see A is a 0, B is a 1. So we find that cell where A is a 0, B is a 1. So that's this cell right here. And we write a 1 because that's the value when A is a 0 and B is a 1. Now let's look for A is a 0, right? A is a 0, B is a 1. Well, that's this cell right here. And the output's 0, so we write a 0 there. And now A is a 1, B is a 0, that's this cell here, so A is a 1, B is a 0, and the output is a 1. So we're going to write a 1 there. And then A is a 1, B is a 1, that's the last thing we have left, and the output's a 0. So this is our Karnaugh map with its values in place. And I'm not going to use all the proper terminology yet because I haven't quite got into that. But what we want to do, or the pattern we want to look for, is we want to find ones that we can group together in convenient size groups. So I can't do some sort of crazy L-shaped thing. In fact, the rule is that they have to be square shapes, meaning that they don't have any indentations, and the number of ones that our groups have is always a power of 2. So that means a group can have 0, of course. It can have 1. It can have 2, 4, 8, 16, so on and so forth. So here we see that we can actually group these 2 ones. We can group these 2 ones here. And this is a power of 2, meaning that the count of ones, there's 2 ones, and that is a power of 2, right? 2 to the power of 1 is 2. So this group is a valid group, and the grouping rules is something that I'll get into later. I'm just kind of giving you a first example to give you all context for everything. Now, what we need to do is we need to find what is in common in this group. If the variable changes inside this group, that means it's going to get ORed out, or it's going to get canceled via OR, right? The way OR works. And so you can either look for what changes and don't add that, or we can just look at what stays the same, what's getting factored out of this group. In which case, A does change, right? It's an A for this, or it's a 0 for this cell and a 1 for this cell. But here, B is a 0 for both of these cells, right? It's a 0 here and a 0 here. So that means we can factor B out. And since B is a 0, that means it's primed, right? B prime. And that's it. That's all we need. So this, we said this function is x. So that's the simplified function using a 2-input Karnaugh map. So the best thing to get good at Karnaugh maps is to just do a lot of practice. So that's what we'll do.